So in this case, we are going to consider as a continuation, working with question number two. 2.1, we were given a question that was on our integration by parts, which had 4 marks. So this whole part, we are given to determine the integral of y with respect to x. And on 2.1, y is equal to this. So that is, we must integrate this whole part that we are given with respect to x. So that's e to the exponent of 2x cos 3x with respect to what? With respect to x. So, as we do understand, guys, as part of our integrals, that we are supposed to consider the basics of our integrals, which is from our N5 application, and considering the part of our N6 where we have got by parts. All right, so where we're gonna consider our by parts, then we have got the trig functions, and we have got completing of the square. So guys, completing of the square. By just looking into our derivatives of your syllabus, you can see that completing of the square is actually out. There's no way that we can complete a square here. The trig form, there is no trig form that is going to have an exponential inside. So the only part that you are left with is by parts, according to your syllabus. All right, or by just looking into the product of two terms, different functions. We have got an exponential and a trigonometric. So once you see this product, you know that you are dealing with what? By parts. You're going to integrate by parts, which we are given our integral. So in your formula sheet, you have got this integral of f of x g prime x with respect to x, which is supposed to give us f of x by gx minus the integral. This time we're going to differentiate our f of x. We integrate our g prime to obtain gx. So this is it. Remember, we referred to choosing of f of x. All right, there's a class that I did which we can use to choose our f of x. But guys, whenever you are dealing with a trigonometric and an exponential like this, anyone, you can choose anyone there to be your f of x. Because we can differentiate an exponential, remember? We can also integrate it properly. Because we can also differentiate that, we can also integrate it properly without any struggle or any hassle. So, meaning to say, anyone, it's a choice. So, going to our islet concept, this one, where we have the order, it's not important. So, these three, they are totally out. We are dealing with what? A trigonometric and what? An exponential. So, on these two, we can choose anyone there. To say it's exponential, it's trigonometric, guys, here, it's in your hands. So as for me, for this one, I'm just going to choose my f of x to be the exponent in the way as it is. I'm just going to take the way that is so that I do not have confusion to say I choose my f of x to be this one. What? Okay, no problem, guys. No problem for this one. Okay, so we're going to let our f of x to be what? To be e to the exponent of 2x. So that's our f of x. E to the exponent of 2x, meaning to say the remaining part, because we have removed f of x from our formula, so the remaining part is for what? G prime dx, which is the remaining part. This one is for our G prime x. So therefore, we're going to have our G prime x dx as what? Cos of 3x with respect to x. So that's it. From f of x, we need what? Its derivative. So let us differentiate our f of x. Considering that we are working or dealing with e, that one. Okay, let's go to our formula sheet. So here I just had to focus on a single part of our question. Sorry for that. I needed the formula sheet. So here we're gonna need, I think, supposed to be page 2. All right, so let's go to page 2, guys, and see what we have got on that part. Sorry for that. So let's have our derivatives. So if you just know these derivatives, guys, just go straight to the question. But as you can see, for our e, I need the one that is to the exponent of f of x, this one. E to the exponent of f of x. So its derivative is going to be what? E to the exponent of f of x times the derivative with respect to x of what? F of x. So in our case, we have this as e to the exponent of 2x. Our f of x, the one that we are referring to here, is what? Is 2x. So meaning to say that's e to the exponent of 2x times the derivative of our f of x. The derivative, our f of x is what? Is 2x. What is its derivative? It's what? It's 2. So that is the condition. So that's 2e to the exponent of what? Of 2x, just like that. So you just needed direct derivative there. Okay, drop the exponent and this one remains as it is. Then integrating our g prime, we're gonna obtain gx with respect to x. So if we integrate a cos, again, we have got this one from our formula sheet, guys, integration. So this is cos here, that is cos. This is your derivative and this is your integration. So as we can see, it's going to be sine ax over a. So it's cos 3x. So it means it's going to be sine 3x over what? Over 3. Just like that, sine 3x over 3. So that is it, sine of 3x over what? Over 3. So that is the integral of a cos. We're going to have plus the constant of integration. Do not worry about that one for now. And another thing, we do understand that whenever we're dealing with an exponential and a trigonometric, we must integrate twice, actually. Okay, this is just going to happen on its own. Let us see. That is it. Let us see, guys. The integral of e to the exponent of 2x cos of 3x dx is equal to what? So that was going to be f of x by gx. So let's see if we're going to need to simplify f of x and gx. If you multiply those two, is going to be e to the exponent of 2x times the sine of 3x. Our gx is what? Sine of 3x over 3. The sine of 3x over 3. So I'm just going to divide everything. Is going to be affected by that 3. So we have got the product of these two minus, we need this part. All right, so that's the integral of f prime x, which we have got, f prime x, that is given 2e to the exponent of 2x by our gx. All right, our gx, remember, that is here. That is the sine of what? Of 3x over 3. So that's it. We're going to integrate this with respect to x. Okay, let's see where we are, guys, and try to simplify. Okay, let me just write this anyways for the sake of everyone to understand. I'm just going to rewrite here. Okay, so here there's no need for us to simplify anything, also just rewrite. We're just going to try to simplify the part of our integral. Okay, so the part of our integral, there is a constant. Actually, there are constants, the 2 and the 3. So this is same as over 1. So I'm just going to take it as 2 over 1 times this is 1 over 3. 2 over 1 times 1 over 3, guys. That's 2 over 3. So that's minus 2 over what? Over 3. The integral of this part which is left, e to the exponent of 2x sine of what? Sine of 3x with respect to x. We must integrate that. We must integrate that. So now it comes to a condition where we need to integrate, but what we are to integrate, it's a product of two terms, different, an exponential to a trigonometric. So we must apply what? By parts again. Apply by parts again. Where we have to choose what represents f of x. So if, let's say, in the first place, you chose f of x to be the trigonometric function, which is the cos of 3x. Maintain that. It means in this case also maintain to choose your f of x to be the trigonometric, which is what? Sine 3x. But in our case, because we chose our f of x to be e to the exponent of 2x, so I'm going to use that same concept. So we are not going to have a repetition, guys. For the f of x, it is the same as above. We chose that one. So the only calculation that we are going to do is on the what? On the g prime, because we know that if we choose this one to be our f of x, the remaining part will represent what? It will represent our g prime dx. So that is the sine of 3x. That is the only part that we can work on integrating this. We're going to have our gx, and integrating a sine of 3x, we can also just consider our formula sheet. That is the sine on our sine ax. We have got the derivative. Then this is part of our integral. So that's negative cos ax over a. So if it is sine 3x as we are given, it's going to be negative cos 3x over what? Over 3. Just like that. Okay, so this is what we need. Negative cos 3x over what? Over 3. So let us bring it here. So that's negative cos of 3x over what? Over 3, plus the constant of integration, which I said for now, we are going to ignore it. So we need to integrate this part on its own, where we choose our f of x, the same f of x as we had that one on top and its derivative. But take in mind that we are integrating this. So for us not to have confusion, guys, let us have our integral here. We are integrating, let me indicate the part that we are integrating now, this part. We are focused on this part. This is the part that we need to integrate. So integrating that part, all right, you can just indicate it integral of e to the exponent of 2x sine 3x, so dx is equal to, you use your formula just before the integral of what you had before, guys. It's going to be f of x by gx, applying our by parts, minus the integral of f prime x gx dx. So remember we said our f of x as before. So we're going to take our f of x as before. That was what? E to the exponent of 2x. Okay, so that's e to the exponent of 2x by the gx that we obtained here, negative cos 3x over 3, okay, minus the integral of f prime, our f prime from our f of x. Remember, this is our f prime, to e to the exponent of 2x, to e to the exponent of 2x by what? gx, remember this is our gx, which is negative cos. So that's negative cos of 3x, everything over what? Over 3. Okay, so let's just try to simplify before we substitute our integral back to that formula. All right, so this is over 1, just numerator to the numerator, that's negative e to the exponent of 2x, cos of 3x over what? 1 times 3, which is 3. All right, let us take our constant outside, but there's a negative, negative. So that is going to give us what? A positive. All right, then 2 over what? 2 over 3 outside of the integral. So that's 2 over 3. The integral of what is remaining? E and what? And cos. Remember, we took the negative before. So it's just going to remain as the cos of what? Of 3x. They're supposed to be with respect to x there. Okay, so this is it. We have what is representing the integral of e to the exponent of 2x sine 3x. But if we consider to say you were supposed to integrate this part here, you were supposed to integrate this part. But if you look properly, this stage is the same as our original question here. So therefore, substitute back. Do not integrate, because you have same thing. You're gonna integrate, integrate, and integrate. So that's why we have got the DI method, derivative integration DI method. So I'm gonna explain that one. Make sure that you become part of the membership, because I'm gonna put that video on membership so that we can have other ways for the sake of revision. All right, so this is it. Substitute. So I'm just going to have our original equation as it is. You substitute the integral of what? E to the exponent of 2x sine 3x dx. So let us substitute that into our whole integral. So that's the integral of e to the exponent of 2x cos 3x with respect to x is equal to this. All right, e to the exponent of 2x sine of 3x, everything over 3, minus what? 2 over 3. So that's 2 over 3. This integral, we have got its resultant. Remember, we simplified. This is what we got here. So I'm just going to substitute this whole part as it is here, this whole part. So we got, all right, let us just have a bracket. So this is what we got on our integral, guys. Negative e to the exponent of 2x cos 3x, everything over what? Over 3, plus 2 over 3, the integral of what? E to the exponent of 2x, the cos of 3x with respect to x. So this is what we got here. So that was the integral of what we needed. So we can combine everything, guys. As we can see, what we need here is to properly see this integral separate on its own. This e to the exponent of 2x cos 3x, because we have it also on this other side. So let us try to separate those so that we can properly see our terms, collect our like terms, this and that. All right. So for the sake of us following, I'm just going to rewrite everything as it is. All right. Just going to rewrite as it is. E to the exponent of 2x, the sine of 3x, everything over 3. So let's expand our brackets here. Since this is a product, so negative to negative is going to give us what? A positive. Then if you multiply, that's going to be the numerators together. So that's 2e to the exponent of 2x cos of 3x. Okay, the denominators together, 3 times 3, that's what? That's 9. Okay, we are done. We move on to this negative to this positive. That's going to give us what? A negative. Then the same thing, numerator to the numerator, denominator to the denominator. So that was going to be 2 times 2, which is 4, over 3 times 3, which is 9. The integral of what? The integral of e to the exponent of 2x cos 3x with respect to x, just like that. So you expanded. In this case, you were to expand the brackets. So from there, we must now collect the like terms, which is that part of our integral, the one that we wanted to separate to say we have this integral and we also have that integral here. So let us combine them. Just take this one to the left-hand side, minus 4 over 9 to the other side. So guys, this is just, it is just like this, 1x. Then it is equal to something, whatever that you have. Then there is negative 4 over 9x. You take the negative 4 over 9 there where there is x. So you're going to add 1 plus 4 over 9. So this is what we are simply having. The minus 4 over 9 added to that integral. There is a 1 which is outside. So you're adding 1 plus 4 over 9, which was going to give us 13 over what? 13 over 9. So that is the whole part that you're dealing with there. Addition, you take this to the other side of your integral, to the other side of the equation, I mean. So it will be a positive. So that's 13 over what? Over 9, the integral of this part as it is, all right? So let us have the integral of e to the exponent of 2x cos 3x with respect to x. And that is equal to, on the right-hand side, we do not have anything in common that we can add. Yes, we can factor out e to the exponent of x if you want that one, or just leave it as it is. So that's e to the exponent of 2x sine of 3x. Everything over what? Over 3 plus 2e to the exponent of 2x, the cos of 3x, everything over 9. Remember, we took this one to the other side. So that's it, guys. We are almost there. What we need is the integral of this part, guys. This is what we need. So what is affecting our answer is the 13 over 9. This one, which is outside of our integral. So you must get rid of this. So you're just going to multiply by the reciprocal, which is 9 over 13. So this whole side, we are supposed to multiply it by what? 9 over 13. Whatever that you do on the left-hand side, remember, must be done on the right-hand side. So that's it. So we are left with the integral of exactly what we were given on our question. This is exactly what we are given on our question. So it therefore tells us that this will be our answer. So let's multiply 9 over 13 times. So this is same like this, guys. 9 over 13 times. This is same as 1 over 3. 1 over 3. So this is it. It's going to be 3 over 13, or just use your calculator. 3 over 13 of this sine, e to the exponent of 2x, the sine of what? Of 3x. You do the same thing. 9 over 13 multiplies this. So it's 9 over 13 times 2 over what? 2 over 9. So as we can see, it's going to give us 2 over what? 2 over 13. So that's 2 over 13 of what we are seeing here, e to the exponent of 2x cos 3x, which I said you can factor out the e to the exponent of x if you want, or you can just leave it as it is. It's not a problem. So this is the whole integral, guys. So do not forget now to add the constant of your integration at the end. So this is your original question. So once you can see that original question, guys, we are done. You're not gonna simplify further and further and further. No, you're done. So you see the process. You have to integrate until you see the original part of your question as it was given on the question. So whenever there is an exponential and a trig, you must expect this to happen, guys. This one, you must expect it to happen, that you integrate twice. You integrate twice. So we had to apply by parts 2 times. That is what I'm trying to say. Choosing f of x where there's an exponential and the trig is not affected, you can choose any one between the two. So I want you to try as an individual where you choose your f of x from the original question that we had. You choose your f of x to be what? To be cos of 3x. So the remaining part, g prime x, will be what? E to the exponent of 2x dx. So that is the condition. So you can work with that one. So the same thing when you are to integrate again, because you saw that when you choose this, you are going to apply by parts again. When you apply that by parts again, the same way that you chose your f of x, maintain that one. To say you chose a trig, you maintain that trig function. If you choose to work with the exponential, maintain that exponential. You won't go wrong. So that is how you can attempt this question. Try as many questions as you can. As you can see, guys, it's a repetition. They're repeating these things, these typical questions, same approach. So we are going to see the DI method on our membership. That will be our next part. Then we move on to another question and so on and so on. So make sure that you just go through. I think I introduced DI method on by parts, which is the simplest method that you can have your answers direct to the answer. Direct to the answer. So that's it, guys. Till we meet again.